What is up, YouTube? Welcome to the House of Doula. Hey, I'm glad to have you. Glad to have you in my garage as always. I'm gonna do a little experiment today with this anemometer here. We're gonna do some fan flow comparisons on a couple fans, so stay tuned. All right, so I thought I'd do a little bit of experimenting here and kind of share it with you guys, share the data that I'm going to find out. So I actually bought a kind of a cheapo-ish anemometer. This is like $34, something like that, 30-something dollars on Amazon. But this measures wind speed, and what we're going to be doing with this is we're going to be placing this behind the radiator, behind the condenser, and actually measuring the amount of suction going through the core of my radiator and condenser. And then we're also putting this in front of my intercooler because it's a turbo car, and we're going to be measuring how much suction is being sucked through the intercooler. We're going to do it on 3 different places: top, kind of the bottom, and the somewhere in the middle. So we're going to be comparing a Spal fan. This is a Italian-made Spal fan that came in my DeWitt's radiator. It is a great fan. And then we'll be comparing it with the ever-popular Contour fan that's installed in the car right now. And if we have time, we're going to test a Blackmagic fan here. I've got a Blackmagic fan that's been sitting on the shelf. We're going to stick this in and power it on as well. So if you've been a fan of the channel, you know this car. You know this is my on-3 turbo car. We just put a head gasket on it, fixed head gasket leak, fixed a whole bunch of stuff on it. It's running amazing. Just got it tuned, and it is hot here in Texas. Okay, we are at a already, mid-90s and up here, and it's only May, so it's going to be a really hot summer. So I like to run AC. I want to run AC. I'm at the age where I like to run, whatever this is, 450, 500 horsepower-ish car with air conditioning. I want to do that. However, the car is still having heating issues. It's not overheating. It's just getting hotter than I like it to. Now, it's pretty common, okay, and it's not getting too hot. We're getting like 210, 213-ish, maybe 215. Sitting in traffic, AC on, running the car hard, etc., etc. So, not a big deal. So I reached out to DeWitt's a few years back, and they've hooked me up with this big 2-core radiator, but each core is 1.5-inch tubes. Okay, so it's actually got 2 tubes, 1.5 equaling 3-core total length width here. It's nice and wide. Now, that being said, I'm having a little bit of issue with it leaking right here. So I'm working with DeWitt's to get this fixed. Maybe even send it in. They're going to weld in a neck on it. I went out and put a Contour fan on. These radiators come with these Italian-made Spal fans. These are great fans. I want to say these are probably 2800 CFM. So we have those fans at 2800. Then we have the Contour fan, which I believe is rated somewhere around like 3200 CFM. So it may be closer to 3000. I don't know, but these are really, really similar in flow. But that being said, I thought, well, you know what? Let's just go ahead and try. I'm going to get a Contour fan anyways. So I bought this actually for Project Ego Brews over here. Ego Brews is getting a custom radiator made right now as we speak. It's got an SVE in it now. I'm using it for mock-up. It's going to be a custom-made radiator from DeWitt's, and then I'll use these Contour fans in that car. But I thought, hey, you know what? Let me just put it on this car. Let's see if it makes a difference. See if it gets the temperatures down. What I noticed was not a lot of difference, but it'll be in the data. I want to see it. I know you probably do too. We're going to measure right in front of the radiator condenser here. We're going to put the meter right behind here. We're going to measure the airflow sucking through the condenser, through a gap that's between the condenser here, about that much of a gap between the radiator and condenser, and through this massive 3-inch radiator. So, being as thick as this radiator is, it's going to require quite a bit of static pressure or a lot of CFM to be able to pull through this. Now, it's one thing having just a powerful fan spin real fast. Another thing having a powerful fan spin real fast and actually move the air, have a strong suction. That's what we want to measure here. I want to measure how much airflow is being sucked through all of this. Now, on top of that, you can see down here I've got my on-3 turbo intercooler. Then again has about a 1/4-inch gap. There's a 1/4-inch gap between all these components here, and it itself is I believe it's a 3-inch also. It may be more than that. It's pretty wide. It's about yay wide, right? Yeah, maybe 4-inch. It may be maybe 4 inches wide. So we're gonna measure here, and then we're gonna measure right down here on the lower part of the intercooler, and then we're gonna raise it up because the intercooler itself isn't covered by the fan shroud. The fan shroud is going to end where the radiator core stops and ends, which is going to be about right here. So really, realistically, up here in my intercooler, the top half of it is actually being affected by air fan, the airflow, from the electric fan sucking through the intercooler, and the bottom half of it here is going to be affected really just by the car, driving, because it's going through the grill here, which is all beat up, by the way, but that's not the point. So we're going to measure up top here in front of the condenser, and we're going to measure, the condenser goes down here too, so we're going to measure up top of the intercooler, which is now going through intercooler, condenser, and radiator. You're talking about 7-8 inches of heat exchange it's sucking through, and then we'll measure down here just see if it's being affected at all just from the pull of the fans. So what we're going to do is take 3 measurements with all 3 fans. We'll see which one the winner is. All right, we're going to do things roadkill style here, cardboard and Sharpie. Okay, so here we go. We're going to go to contour first. Contour. 1, 2, 3. The winner of this, it gets us down my car. That's all. Also, since amperage and voltage has a very important play in high drawing fans, I want to make sure the results are the same between all of them. So I've got my battery here, it's been on a charger, so we're going to keep this on the battery to make sure that the voltages stays up nice and high. We're not going to run. Now there's nothing to this anemometer here. It does have a direction of airflow, so we want to make sure it's sucking in this way towards the airflow into the radiator. Now there's different units of measurements here, but in this case it doesn't really matter. Just for the sake of this test, we're going to use miles per hour here. And then what we're going to do is we're going to set this as a minimum and max, so it'll actually measure min and max. So if I put this on maximum speed, so there you go. The fastest that little blow test was 3.6 miles an hour. Okay, and then we'll just reset it here. All right, so let's do this. I'm going to start this in 2 different areas. Let's start this one first here, or 3 different areas. So I'm going to place this right on top of the intercooler. Okay, so it's right up against the AC condenser at the top here. Let's do it. I'm going to turn it on, the key on, and I'm going to have the AC on since the fan triggers. The AC is triggered by the fan. Okay, we'll give it a second. Okay, let's see what we got here. Anemometer says 6.9 miles per hour. Okay, I think what I'm going to do, I'm going to flip it upside down and kind of get the bottom of the core here just to make sure there's no difference. Okay, that was 6.9. Oh, 7.8. There's a big difference. So that was the difference between it being up top here versus upside down up against the bottom of right here. So we're going to mark both. That was 7.8 miles per hour. All right, so let's do this. We're going to have 4 measurements now. Okay, we're just going to go down kind of from top to bottom here. 6.9, 9, 7.8. All right, in this test, I've got it up towards the top of the intercooler. 3.3. Now I'm going to reset it and put it on the bottom here of the intercooler. 2.9. Okay, 6.9, 7.8, 3.3, 2.9. Okay, let's install the Spal fan. Also notice on the contour fan, or at least it should be noted, that I've got a nice seal on it here. I've actually used some of the rubber that came off the Black Magic fan, so that when it was installed, we're talking about a nice fit press on the corners here, on the bottom as well. So it's on all 4, pressed up against the radiator. Have a nice seal, no leaking air coming in from the cracks. All right. Okay. Out with the contour, in with the Spal. These are heavy fans. This is a nice fan, no doubt. These DeWitt's radiators come preset up with welded crossbars to support their fans, which is kind of nice. And it's also kind of nice that the contour fan actually set on top of that bar and it wasn't in the way of the blades. So yeah. Okay, here we go. Spal test number 1, the very top of the condenser here. Ooh, they're a lot louder, I can tell you that much. Okay, let's see what we got here. Okay, 5.8. We got 5.8 at the top level here. 5.8. I don't know why. I really want the Spal to win here. Spal test number 2. Okay, 7.8 on the Spal number 2. Same exact location. I'm letting each run 5 seconds. Okay. We got 3.1. 3.1. Okay. 2 miles an hour. Interestingly, I actually have more room in the engine bay with the Spal fans. These are some pretty beefy fans, but the contour fans take up a little bit more depth than the Spal fans because it does rub against this AC line here, and the Spal fan does not. Alright, man. For the sake of science here, I've got this on about as good as I can get it here. Yes, it is clamped on. Yes, it's pushing it up against the seal as much as I can. I've got rubber on both sides. The bottom is sitting up against the metal bar, so it's no different than the Spal fan is. However, I do got rubber smashed here on the sides, and I had to kind of push it up against the radiator because I'm not going to mount this permanently. We're just trying to get it up against the radiator for a test because it is awfully close, very close to the water pump. Now, that's one thing, the benefits you get with the dual fans is typically you have more room away from the water pump. This is a single fan, of course, so they're going to see a difference. However, the shroud itself is pretty good on these Black Magics. However, look how much room we have on the sides of a standard Fox body radiator. So, yes, I could have centered it up some more, but this side has quite a bit of space showing as well. In fact, it's got about the same, so it really is center. This does not cover the whole fan surface area, I mean the radiator surface area, so that's not ideal. So I think without a doubt, you know, the Spal and the contour fan is going to blow this one away, but hey, just for comparison's sake, let's see what happens. Here we go, test number 1. Flexolite Black Magic. Okay, 6.5. Okay, all right, 6.5. Okay, let's do the Black Magic here and setting number 2, and we're at the stick number 4 over here. I know this is a mess, man. And towards the center of the core, 7.6. Interesting. Okay. Okay. Okay, 3.1. Okay, we got 2.2. Okay, let's look at the results. Okay, so I went ahead and just put them on the board here, so hopefully you could better see it. So again, the placements here of the test were number 1, top of the radiator behind the AC condenser. Position number 2 was kind of on the top of the intercooler, but against the AC condensers, just lower. Which is more center in the fan. This is pretty well centered into the fan here, or the fan shroud. And then spot number 3 here is on top of the intercooler, and number 4 is on the bottom. So again, we've done this on 3 different fans and then averaged them up. So the contour fan was 6.9, 7.8, 3.3, and 2.9. It is a clear winner. It had higher numbers in all 4 areas. And I think a lot of this has to contribute to just how well I sealed it with the rubber around it. So we've really sealed up against the radiator, and we're pushing as much CFM through all areas as we possibly can. And the proof here and the numbers definitely show that. The Spal, I thought, was actually right behind it. And what surprised me was the Black Magic fan actually averaged a higher number than the Spal fan did. Even though that the number 1 position was quite a bit higher than the Spal fan. In fact, I was surprised up top here that this number was so low at 5.8 miles per hour. So what's interesting here is I'm guessing that this upper area just has to do with maybe the lack of shrouding and or the lack of the fan covering the top of the radiator, since it actually sits and screws into that bar they have in place here and here. there is some exposed area, you know, not much, but there's some exposed area on the top of the radiator up there. Now, it wasn't all the way up against the top. I mean, realistically, this is really close to where, you know, the anemometer was sitting. So number one here, in that position at 5.8 seemed a little bit low for the Spal fan. I tested it a couple times, and through all these tests, guys, I had the battery charger on, and we had it charging and made sure the battery was topped off. All these were only ran for 5 seconds, so not really long enough. And between the tests, you know, there was enough resting period, especially between switching the fans out, resting period for the battery to recharge. So don't go saying that by the time I got the Black Magic fan, you know, we were out of battery charge. That's not the case. It took me a while to get the Black Magic fan fitted in. But the Spal fan here was equal on number 2 here. So right here in the center, it was pulling the same CFM as the Contour fan. Number 3 was basically the same, and number 4 was just a little bit lower. So I was assuming that this would come into a close number 2 with the Contour fan, but I put the Black Magic fan on, and it turns out the numbers were actually pretty good. The top number was low. Again, I don't think there's much coverage on it, and you have to consider, you know, the homemade job I did on the shrouding with the rubber, the sealing it up. But nonetheless, we got a 7.6 here on number 2, so these two numbers are pretty good. And then you're going to see a considerable drop. Now, why you're seeing a drop here is because we're looking at intercooler fan. You're increasing, you're adding 3 to 4 inches of intercooler space between this surface area and the fan surface area that starts back here. Okay, so you're really talking about trying to push air through this whole section here, guys, and that's a lot. It's like 7 or 8 inches. You're talking about 4 inches here, you know, an inch maybe there, and you're talking about 3 inches here with the gaps between it. So, you know, I mean, it's probably over 9 inches between this. So yeah, you're going to see higher fan flow through this area here. But what's interesting is, and what should be noted is that half of your AC condenser is getting, you know, your 7.8, you know, your 7.6, and these two numbers here. So half of the condenser is here, and the other half is being shrouded by your intercooler, okay, which is going to get number 3 and 4. What that means is really only half my condenser is going to get its full airflow, okay, and the other half of it is being used or consumed from the intercooler taking up the CFM. Now, that being said, I'm not a scientist here, I'm not an engineer. I'm sure the CFM in this measured area is higher than it would be here, right, in between and in the back of it, because, you know, it's closer to the fan. So maybe these numbers are closer, maybe not, I don't know. But the truth is that when you're measuring from the surface, the intercooler is getting robbed here really because of all the room, you know, being sucked through it. That being said, my intercooler works very effective. The temperature drops and the turbo are really good. But hey, guys, the clear winner here is the Contour fan. Interestingly though, the Spal fan came in second. Now the Spal fan, or Spal fan, I'm probably saying it wrong, does have the most clearance out of all 3 of them between the 3-inch radiator and the engine. So that's something to be said for too as well. But it was still interesting. These are really close, but really you're seeing, in my opinion, the stronger CFM. Now again, let's talk about this real quick. So your 3.3 and your 2.9, it's going to take more of a powerful fan, not necessarily the rated CFM, but take more of the powerful fan to be able to push that air through a thicker space. Okay, now there's a scientific word for this. It's like a static pressure or something like this. I'm sure we're gonna get corrected. Again, I'm not an engineer. This is just my own test to figure out which fan I want to use, but I thought I wanted to share it with you guys. But I think this is where the Contour fan is really kind of winning here, because it's able to pull in so much more air through these area here. So realistically though, if you're looking at just these numbers here, they're all very close, okay? I mean, you're talking about very close numbers. You know, 3.3, 3.1, 3.1, 2.9, 2.0, 2.2. Realistically, 3 and 4 here on all 3 of the fans, we're doing about the same. It's just you get a slight edge here on the Contour here in the bottom of the intercooler. I was surprised that the bottom of the intercooler was actually almost pulling 3 miles an hour, being that it's not even shrouded behind this area back here at all. So that's pretty cool that it's still picking up some air suction. And again, I think this is due because of the seal. So anyways, take this data, do what you want with it. Again, don't go flaming me here because you're an engineer and I did all this and this wrong. This is just my own, hey, I want to see, I need a number, some sort of data that tells me which fan's sucking as much as I can through all the crap in front of my car here. And in this case, I'm going to leave the Contour on it. Probably order another Contour for this one, or probably use a Spal fan on the Eagle Brews here because it's going to be plenty for that little EcoBoost motor. Yeah, hey, that's it. Take this numbers, do what you want. Remember, it's not always the CFM rating that counts. It's the static pressure that the fan is able to pull through, how much power it has, okay? Think about it this way. Think about it as the fan may be, 3,500 CFM when it's just sitting here still and with nothing in front of it. Once you put a load in front of it, it's like putting a load on a motor. It's how much can that fan's motor compensate for the load of things you stacked in front of that fan. That starts setting different fans apart, because that static pressure that's in front of it is going to put a draw on the motor and cause it to, use more amps to pull air through it. So that's where the motors really shine, right? It's the ones that can power through that thick stuff you stick in front of it. All right, so there's the results. Hey, it's easy to see why the Contour fan is such a popular fan to go to, guys. It is by far the cheapest fan out of the Blackmagic and the Spal fan by like hundreds of dollars. It flows more air, and on top of this, just doing these tests, I noticed it's quieter. So it's the quietest fan, flows the most air. So guys, are cheap. These are cheap, like $130 on eBay. You can still get them new, not used, not off the pull car, not junkyard. 130 bucks, you can get a Contour fan used. So anyways, I have a totally different video on installing a Contour fan. Go way back years ago. You can watch that one if you want. I thought this was kind of a fun comparison. I'm going to end up using the Spal fan for Eagle Brews here and keep the Contour fan on my turbo car here. But that's it. We're done with this video. Hey, make sure to follow my Instagram. Make sure to go to houseofdoula.com for all the latest videos and all the t-shirt swag junk like this crap right here. It's pretty cool, I guess. So you get yourself shirts, yeah, we got lots coming. I got lots of stuff to show you on Eagle Brews here. That's coming up. We'll see you next time on House of Doula. Thanks for watching. Bye-bye.